This one, Iryani Ismail. She's from Faculty of Science and Marine Environment, University of Malaysia, Terengganu from Malaysia. And her topic that we'll present now is antibacterial activity of the silver nanoparticle synthesized from the polychaete extract, Marphysa moribidii. So please present your work.
Right, thank you to Mr. Chairman. I would like to share our works together here today. So now I think everybody is quite aware that we're having COVID-19 pandemic throughout the world, but I'm not sure how many of us are aware that actually we are having more pandemic in the future. Okay, so we're having more pandemics in the future. Actually, it is based on according to WHO, where they reported in 2020 in the World Economic Forum, actually they have 7,000 signals of potential outbreaks every month. Okay? So that's indicating that infectious diseases are a very significant health problem globally. So now, because of COVID, we hope we can combat this disease through the vaccines. But at the same time, actually, we need more antimicrobial agents at the same time and to combat the disease together with the vaccines. So based on the current technology, actually, we can develop the most significant antimicrobial agent if we can cooperate nanobiotechnology in producing new antimicrobial agent as well. Okay, so why nanobiotechnology? So maybe we are quite familiar about nanotechnology, but today I would like to highlight more about nanobiotechnology. That means nanotechnology from biological organism. Nanotechnology mostly we can identify this as a metallic nanoparticles from size 1 to 100 nanometer. So they are very advanced and unique character because they have antimicrobial activities. And even they are small, actually they have large surface area per volume. And nowadays, because of COVID, they have a very high demand in producing silver nanoparticles throughout the world, up to 3 billion, even higher now, and by 2024. So why nanobiotechnology? As I mentioned, we use biological organism. For example, here we can use microbes, we can use plants, even we can use marine organism, like in our study that I would like to share today. So by using these types of biological organism, actually we can synthesize nanoparticle from the biological activity to produce nanoparticle in nano size, and hopefully we can reveal their antimicrobial activity. So in our study, we use marine organism known as Polychaete or marine Polychaete, also known as blister worm. This marine Polychaete, normally we use them as a fish bait. Okay? We use our local marine Polychaete known as rod bakau. We can collect this type of Polychaete from mangrove area, and we managed to use this Polychaete to synthesize cold nanoparticle, and also it is very useful to use in wound healing activity. But today we'd like to highlight more about silver nanoparticle synthesis. So we know that silver nanoparticle is very excellent in terms of antimicrobe, but today I would like to highlight more about antibacterial properties. And from this study, actually we want to discover whether this type of Polychaete can synthesize silver nanoparticle. And from the synthesized silver nanoparticle, we want to observe their antibacterial activity. So the main objective of this study is we want to discover the potential of Polychaete, Marphysa moribidii, in synthesizing silver nanoparticles and their antimicrobial activity. So it is our methodology. So we need to go to collect the sample, we do the sampling. Then we need to do more Polychaete extraction and so the silver nanoparticle synthesis. And then how we want to confirm the silver nanoparticle synthesis, we need to do some tests, or we call them silver nanoparticle characterization. These are a few steps, few methods that we use in our study to characterize the silver nanoparticle, known as visual observation, UV visible mist spectroscopy, dynamic light scattering, scanning electron microscopy, transmission electron microscopy, Fourier transform infrared spectroscopy or FTIR, and X-ray dispersion. After we validate the silver nanoparticle formation, then we can do the antibacterial assessment using these four methods known as this diffusion assay, minimum inhibitory concentration, minimum bactericidal concentration, and also time kill assay. So as I mentioned earlier, that we need to go to sampling. We need to collect the sample from mangrove area. Normally, we also collect some data from the sampling site. Then we also maintain the polychaete in artificial aquaria and also in our hatchery. Then we do a few steps in terms of extraction. Here I can show you that we use only 10 grams of polychaete and add 100 ml of distilled water. Then we pulverize the polychaete and filter it using the Waterman filter paper number 1. And then we add silver nitrate together with the polychaete, incubate for overnight at 30 degrees. And then we can synthesize the silver nanoparticle within one hour up to 4 weeks of the study. So how we characterize the silver nanoparticle synthesis? So as I mentioned to you that we use the visual observation to detect color changes. We use the UV-based spectroscopy to measure the formation of the silver nanoparticle peak using the surface plasmon resonance peak. We also use the LS to see the particle size, particle distribution, and then we confirm the morphology of the silver nanoparticle using SEM and also TEM to know the exact size of the nanoparticle. And then we want to measure how the exact biomolecule involved in the synthesis. And we also did X-ray diffraction to confirm that silver nanoparticle that we obtain directly from the polychaete, not from the environment. So here is a result that we achieved from this study. You can see the color changes from red color to the brown and dark brown within 1 day, and even it is stable even up to second week of the study. Then we use this spectroscopy analysis. You can see the peak of our sample compared to the control. That control we use silver nanoparticle from sigma. Then we can detect the peak. Our peak is almost similar to the control peaks at 397 nanometer compared to control 395 nanometer. So there's within this peak, actually we can identify actually the silver nanoparticle in the round shape. And then we want to measure the size of the nanoparticle briefly. So we use BLS. From the BLS analysis, we found the average of the size in 59.42 nanometer, but it is just only a roughly observation. So that's why we still need TEM to measure the actual size of the nanoparticle. So we use SEM and TEM to confirm the morphology and also the actual size of the nanoparticle. And from the microscopy analysis, actually we confirm that SEM from through SEM, our silver nanoparticle was in spherical shape, and their size actually was 17.23 nanometer. That's actual size of our silver nanoparticle synthesized from the polychaete. And then we also measure what actually bioactive compound involved in the synthesis. And through the FTIR analysis, we found that carboxylic acid nitriles, alkalines, aromatic amine, and alkyl halides involved in the silver nanoparticle synthesis from the polychaete. And we also confirm that our silver nanoparticle synthesis solely come from the polychaete and not from the environment, which we confirm through the SRD analysis here. After the silver nanoparticle characterization and validation, we now move on to the antibacterial assessment. So for antimicrobial study, we just focus on antibacterial tests. So we, as I mentioned to you, that we use 4 types of tests here. So we use distribution, MIC, MBC, and time kill assay. So we use this concentration, so 1.7% up to 100%. So we use 2 types of controls in this study. We use gentamicin for the antibiotic control. We also use silver nanoparticle commercially purchased from Sigma. And we also use a polychaete crude extract as a negative control. In this study, we choose we selected 4 types of bacteria. There's 2 from gram-negative and also 2 from gram-positive.
Sorry, 3 minutes remaining.
Right. So we're going to from the distribution method. We can see the zone, very big zone inhibition from the study. So from the study, actually, we can conclude that the concentration of the silver nanoparticle can be used from 25% up to 100%. And there were no inhibition for the lower concentration. It is most probably because not enough silver nanoparticle concentration in that concentrations. So from the MIC and also MBC analysis, we found that from this test, actually we confirmed that we need to use 50% up to 100% of the concentration to get the highest effects of the study. And from the ratio, we found the MBC and MIC ratio from our sample when tested on the bacteria was 2. That means it is very less toxic and can kill the bacteria. And from the time kill assay, we also found that actually our silver nanoparticle can kill all the 4 types of bacteria, especially from the gram-negative when we compare with the positive control from gentamicin, also called silver nanoparticle from Sigma. You can see this green color is a positive control. That means silver nanoparticle from Sigma. There's no inhibition at all. And this one, blue color is growth control. That means untreated bacteria compared to our sample. In yellow, in green, and also in blue color can inhibit the bacteria as soon as 4 hours up to 24 hours. And from the time kill assay, actually we found that the actual time we can kill the bacteria using the silver nanoparticle, it was at 6 hours. This means almost 90% inhibition can be observed after 6 hours and up to 100% after 24 hours. And we also found that the gram-negative shown the most sensitive effects towards the silver nanoparticle. So as conclusion, we confirm that we can synthesize silver nanoparticle from the polychaete, and we managed to characterize and also validate the silver nanoparticle formation using several methods. And through the antibacterial assessment, we also confirm that our synthesized silver nanoparticle can inhibit the bacteria, especially from gram-negative bacteria, E. coli and P. aeruginosa. It was at 9 hours. It was about 90% and up to 100% when we tested after 24 hours. We'd like to thank to our funders, to our group, and our references. That's all. Thank you.
Okay. So from now, this is time for the question and comment. Is there any question from the audience? Please.
Yes, we have two questions from the audience. The first one is, what is the concentration of Polychaete synthesizing silver nanoparticle used in inhibition bacterial growth?
Come again?
What is the concentration of Polychaete synthesizing silver nanoparticle used in inhibition bacterial growth?
That's I mentioned that we use from 100% of a
100%.
right?
Okay.
From 1.7% up to 100%.
Okay. The next one is, in the method of antimicrobial activity, how many time points were tested? Since the results show that at 6 hours, the nanoparticle could inhibit bacterial growth.
Yeah, we tested every 2 hours.
2 hours?
So 2 hours, 4 hours, 6 hours, up to 24 hours. And then we measured that 6 hours the best time to kill the bacteria.
Thank you.
Okay, are there any questions from here? Okay, for my question, I'm not sure for you synthesize the silver nanoparticle, right? And the time for the formation is 2 weeks, right? Not sure which slide. Can you go to that slide? Maybe 1 week or 2 weeks, something like that. No, again. Yeah, this one. Oh, this is the color change, right? For the color change, sorry, I'm not sure for your time for the synthesize is 2 weeks. Can you open your microphone? I cannot hear you. Can you turn on your microphone? I cannot hear you anything. Dr. Janjuli, can we turn on her microphone? Because she cannot.
Yes. All right. Thank you.
Yeah.
Because I don't know why I can't unmute myself. So actually, yes. Actually, we synthesize within one day, but actually we also measure the formation every single hour. Every single hour to see the silver nanoparticle formation, and we can detect the formation started after 4-hour incubations. So, but the most significant one is after 1 day. That's the most stable one. So from
and for the sample that you apply is just for how long time?
We did the synthesis up to 2 weeks to see.
2 weeks.
Yes.
How about your opinion? I think it's too long time, right?
Yeah, because we want to see any effects during the time.
Yeah, and I also think that your major is how can you control, you fix the size, because if I see your average size of the silver nano still large, right? If your characterization result, I think maybe if you can reduce or you can fix the size, you can control it. I think maybe it's much more matter for your field, right? Your work.
Yes.
Yeah.
Thank you.
Yeah. And how can you make sure? I mean the polychaete, right? How can you make sure their structure? I mean the purity from your extraction.
Oh yeah. Actually, at the beginning, we also measure the species. We identify the species of the polychaete because we one of our team, our member, he is a taxonomist, so he identified the species. After that, we only can use the specific species for this study. Because we also measure, we also did study from different species, but only from this species showed the best result.
Yeah, that's I see. I see. And
so we run out of time for this.
Okay. Thank you very much for your presentation.